as we know that OSPF or Open Shortest First Path is widely used Interior Gateway Protocol designed specifically for IP networks. It is classified as a link state routing protocol which builds a complete map of the network topology. OSPF router technology share link state advertisement with one another to build a synchronized database of the network. From this topology map, we use OSPF in our network automation that calculate the shortest path to any destination network using an algorithm. As a networking equipment gets more complicated, setting up routing protocol like OSPF in multiple servers by hand is time consuming and prone to mistakes. Network automation is necessary to make setting easier to understand and use while also making the network more reliable. Ansible and GNS3 will be used in this project to automate OSPF routing in the three-tier hierarchical network topology that being suggested. You can use playbooks written in YAML to handle and organize configuration across machine with Ansible and GNS3, an open source automation platform. So, this strategic network segmentation using OSPF areas and separation of routing functionality across topology tiers improve stability, performance, security, and efficiency. So, for project specification for our network automation that we use OSPF in our topology, so we use GNS3, Netmiko, and Python 3. So GNS3 is a network simulation software that to create a virtual network topology and simulating complex network configuration without a physical hardware. And Netmiko is a Python library for simplifying task network automation, and it can managing and automating network device like routing and switches. So Python 3 is a programming language. It's widely used various purpose including web and also automation and scripting. Next, the other project specification that we use in our topology that we make network automation, which is OSPF, we are using VMware and also SolarPutty. So VMware, as we know, that is a virtualization and cloud computing software that creating virtual network and in testing and development. So for SolarPutty, we know that graphical access client for Windows, and it provides user-friendly interface that connecting and managing that support SSH client protocol, and it simplifies connecting to network device using command line.
Okay, so my part is to present OSPF technology. So this is our topology diagram. We use the hierarchical topology. Basically, in this topology, we use 5 routers, 4 switch, 3 PC, and 1 network automation and network address translation (NAT). So router is the backbone of the network, connecting different segments together. They determine the optimal path for data packets to travel through the network. So switch are used to connect devices within a network segment. They use a MAC addresses to direct network packets to the correct devices. So next one is computer. There are the end devices or hosts in the network. There are the devices that communicate with each other over the network. So next is NAT, which is network address translation. The cloud icon labeled NAT indicates the presence of a network address translation service. NAT is a method used in IP networks to remap one IP address space into another by modifying network address information in the IP packet headers while they are in transit across a traffic routing device. This is typically used for security and connectivity reasons, such as allowing multiple devices on a private network to access the internet using a single public IP address. So next is the IP address table. So this is the IP address for each router. So we have 5 router for the router. So the all router we have 3 interface. Uh, for the router 5, we have fast internet 00, fast internet 01 and then the serial 00. So for the router 1 until router 3, we have a same interface, which is fast internet 00, fast internet 10, and then fast internet 20. So for the router 1, ID is 1.1.1. For the router 2, ID is 2.2.2. And then router 3, 3.3.3. And 4 is 4.4.4. For the router 1 and then the router 4, we use the type core layer, while the router 2 and router 3, we use type distribution layer uh, for the two router.
Hi, Assalamualaikum. My name is Muhammad Izaki and I will continue the presentation with our project methods. So, for the first step, we must understand the proposed network topology. We have proposed for a hierarchical topology for centralized management, scalability, and defined pathway. There are 5 routers in our network topology alongside a switch for each individual routers and a end device for each router. There is also a network automation device in R5 where we will input the automation script that will be sent to each router for the OSPF automation. So for the second step of our project methods is to identify the router's configuration and determine the OSPF areas and addressing scheme. So we have decided to follow this IP addressing table, which are which each router will be implemented in one OSPF area with their respective IP addresses and all for the same subnet mask. So for the next step, we must install the VMware and set up the virtual machine itself, since we have decided to use this virtual machine in order to ease of use for our project. And after we have finished installing and setting up the virtual machine, we must install the GNS3 on the VMware and then configure the Solar Putty as the terminal program for the GNS3 software. So then we can build the topology as we have proposed accordingly and connect all the devices in the topology itself. We can proceed to the sixth step of our project method by creating a Python script for automating the OSPF for all routers using the Netmiko library in the Python. IP addresses, username, and password should also be defined in order for us to make the router configuration become easier.
Alright, so my name is Muhammad Akib bin Anwar, and today I'm going to proceed the presentation with the Python automation script. So as you can see, this is the full script that we will run inside the VM, which I will show later. So as you can see, these are the routers. I have R1, R2, R3, R4, and R5. So it will take all these values and use it to SSH into the router when we execute the script. So there are also global configuration. So we need to include enable commands and configure terminal command, as well as the OSPF configuration command itself. So for this one, we use the router OSPF 10 and we enter it into the interface and we execute the command IP OSPF 10 area 0, which is easier compared to other method of configuring OSPF. So that is all on the script part. So next, I will proceed with the demo. Alright, so next we are going to see our GNS3 configuration. So as you can see, this is our topology, which uses 5 routers and 4 switches, each connected to an end devices. So for our topology, I'm going to use network automation Docker container, which we will run script in and act as a virtual machine for this topology. So network automation also has Python, Ansible, and Netmiko library pre-installed in it, which will help me doing my script. So firstly, I'm going to try to ping each router to see that it's not connected. So from right now I'm in network automation, I will try to ping this interface as 10 in R1. So I'm going to ping 10.0.5.2. So as you can see, the destination host is unreachable. I'm going to try to ping another, which is R2F1. That will be 10.0.2. No, dot 1.2, sorry. Still destination host unreachable. And if we go to each individual router, will be IP route, show IP route, there are no OSPF connection. So before this, I set up static route in each F2 interface, uh, the LAN interface here, because I want to SSH using the network automation. So I need to set up a static route in order for them to connect with each other first before I can do my OSPF configuration. So right now I will think I will proceed with my OSPF configuration. So yeah, as you can see there, when I show IP route, there's no OSPF. Alright, so we will proceed. So I have my configuration here, the OSPF configuration, then I will run it using Python 3 configuration.py. So it says configuring OSPF in router 1, configuring OSPF in router 2, and so on. Configuring OSPF in router 4, and last one. So it says OSPF configuration completed in all routers. So supposedly I will be able to ping the interfaces that I ping just now that is unreachable. So firstly I'm going to try to ping 10.0.5.2. So I'm trying to ping it. So as you can see, it is reachable right now. I'm going to try another one. Right, unreachable. Let's try again. Alright. Okay, so we have a big problem here in router 1. So I try to ping this on R2, sorry. So I will be going to R2, show IP route. Yes, there are OSPF configuration. Let's try again. Yeah, right now it's connected. So I think that is all from me in the demonstration part. Thank you.
So lastly, conclusion. The methodology and network automation for our topology or SPF section outlines the general steps involved, such as analyzing the topology, defining and addressing, creating inventory and playbooks for automation, testing the automate configuration. However, specifics are lacking on the actual implementation details, command use, topology, and addressing design, playbook code, test cases, and test result. Key gaps include the automation code details, network topology specifics, verification of correct OSPF operation after automate configuration, and analysis of test case pass or fail rates. Additional implementation, representation, and result coverage would help ascertain the outcomes of the automation project. So that's all from us. Thank you.